Hello from China. Today, I want to present the topic which is the influence of dynamic and plyometric exercise on knee joint motion for counter-movement jump performance. This research was developed in the Dongguan University of Technology in Guangdong in China. And I want to thank also my co-author, also Mansour from King Saud University from Saudi Arabia. First, I would like to start asking a question. Could dynamic exercise, plyometric exercise, and knee joint angles negatively affect or influence counter-movement jump performance? Why is the reason that I'm asking this question? It's because the counter-movement jump is a test that is widely used in monitoring athletic performance. And the difference in counter-movement jump performance are related to the effectivity use of the stretch shortening cycle, wherein the muscle function starts with an eccentric action followed by a concentric action. The literature report that the contribution of the knee and hip joints with a large or small range of motion and the effects of lower limb muscle strength on vertical jump performance. So for this reason, and the reason that the physical education system in the college or in China, the students did not use other kind of exercise during the preparation before testing. They are only using traditional warm-ups, which includes typical warm-up from a PE lesson. Normally, they will not include this type of exercise. The procedures that we use for this research includes the My Darfish Express with a 2D video analysis. We use the My Darfish Express with 8 Hz and My Jump 2 for the collecting data. And we implement this app in the iPad Pro iOS with system 11.3. We also use the GoPro Hero 5 Black version, recording at 240 Hz. This iPad and the GoPro camera was located in a 1.5 meter aluminum tripods with a 90 degrees, and the GoPro camera was located 2 meters facing the subjects in the sagittal plane. The iPad camera was located 3.70 meters facing the subjects in the frontal plane and zooming into the feet. The purpose of this study was to analyze the effects of the dynamic and plyometric exercise and to compare the efficacy in improving jumping kinetics among college physical education students. Then we would like to determine during the counter movement moment the knee joint angle that was obtained and the possible changes that it will have in counter movement jump kinematics. In this study, the participants were 45 male college non-athletes with a mean age of 19 years, and they all writing consent, and we received the approval from the institutional review board to do this study. So the subjects were divided in 3 groups, and we evaluated these 3 groups in this counter movement jump test. So the first group was the plyometric group, then we have a dynamic group and the control group. The plyometric group performed a 15 minutes warm-up that includes the exercise that you can see there, a squat jump, counter movement jump with and without the arms and jumping lunge. The dynamic group that includes warm-up based on dynamic exercise, which include the, for example, jogging with oscillation of the arms back and forward, lateral shuffle, karaoke back and forth, high knees, butt kicks, all this kind of exercise. And control group was using warm-up based on traditional exercise. We're using just traditional exercise like flexion, extension, rotations. All of the students who participate in control group did 8 repetitions, and just as a traditional warm-up or exercise that they were using in the PE class. For the kinematic and the statistical analysis, we collect the data using my Darfish Express application in the sagittal plane. Here I will play the video that as you can see how the student performed this counter movement jump. This video is collected from the GoPro camera that was located in the sagittal plane. And We collect also the knee angles, the counter movement jump height, push-up, flight time, velocity, force, and power. So the convention to collect the data from the during this jump, during the counter movement moment, was measuring the knee angles using the knee joint as a reference point in the direction of the lateral condyle along the fibula, and finishing at the ankle joint, and from the lateral condyle to the greater trochanter, finishing at the hip joint. This is the frontal plane. As you can see, this was video was collected from the iPad Pro, and we use the statistical analysis to collect the data from the MyJump2 app. Here you can observe how was the testing protocol, and we used multi-factor analysis SPSS with p-value from 0.05. The effective hands dip was a small 0.2, medium 0.5, and large 0.8. Well, the results that we found that the push-up, force, and power, the main effects among the group, showed significant difference, and the p-value was equal to 0.00. Conversely, the flight time and velocity did not show any significant difference. And related to that, you can see in the table, we present the results with the mean and standard deviation. The CG is control group, PG is a plyometric group, and DG is a dynamic group. So the difference in the knee angles kinematics may be associated with improvement of jump performance. We also determined that the plyometric jumping exercise utilized the stretch shortening cycle can yield a different ratio of motion. And for the other results that we found, that among the control group, dynamic group, and plyometric group, the jump height was a p-value equal to 0.68, and the knee angles did not show any statistical difference. Here you can observe a photo of 3 different angles during the counter moment from the My Dartfish Express app. So in the discussion, we can talk about the knee angles may be associated with improvement of the jump performance. This plyometric and dynamic exercise will induce explosive force and power. And related with the effects of plyometric and dynamic exercise in counter-movement jumping PE, we found that this will induce explosive force and power, increasing the neuromuscular function, adequate a range of knee motion through the video analysis, and the greater force of the lower limb extensor muscles will contribute to have better counter-movement jump performance. These exercises are not difficult to perform and to implement during PE class, so the students can accept and perform this exercise in an easy way. So teachers can use this also to motivate the students to participate and before testing for having a better jump performance. In the conclusion, we understand through this 2D video analysis, we understand the range of motion, the difference on the range of motion, and distinguish jumping kinetics using mobile applications that are practical and we can implement in the field. We can also use this exercise and this equipment and these apps in the PE lessons, in the real-time in PE lessons, and this exercise and understanding the range of the knee motion will help to enhance jumping kinetics. So this plyometric and dynamic exercise can help to improve the range of knee joint and counter movement jump. For this reason, we consider that observing and evaluating the knee angles during counter movement phase and implementing this plyometric and dynamic exercise will help also to improve this jumping kinetics. I would like to thank you everybody for your attention and stay safe. Goodbye.